circuit analysis, sinusoidal steady state analysis. So in this video, we are going to discuss about RC series circuit, how to solve the problem in RC series circuits. So if you see the figure here, the resistance R is connected in series with a capacitor, right, that is connected with a voltage source V, right, and the current I is flowing through the circuit. I is the current flowing through the circuits. Right? I is the current flowing through the circuit, and VR is the voltage across a resistor, and VC is the voltage across a capacitor, and the VR value is voltage across a resistor is I into R. Here the voltage is in phase with the current. If you see VC, that is voltage across capacitor, is I into XC. Here the voltage is lags behind the current by 90 degree. Okay. Is the important term. Okay. Now you can see the formula. The impedance value Z is square root of R squared plus XC squared, right? And the phase angle is tan inverse XC by R. So here it's a leading one, and the power factor is cos phi. The value is R by modulus of Z. The reactive power is V into I into cos phi. These are the formula for calculating the problem for RC circuits, RC series circuits. Okay, now we will see a problem. The capacitor having a capacitance of 10 microfarad is connected in series with a non-inductive resistance of 120 across 100 volt and 50 hertz. Here the 10 microfarad capacitor is connected with in series with the resistance of 120 ohms across 100 volt and 50 hertz. The problem is calculate the power, current and the phase difference between current and the supply voltage. So we have to calculate power, current and the supply voltage. Okay. So we'll see first one. To find the current equal to V by impedance Z. The impedance Z formula is square root of R squared plus XC squared. So square root of R squared plus XC squared, and the R value is given 120, and the XC value we have to calculate. The XC value is 1 by 2 pi FC. So the XC value is 1 by 2 pi FC. So 1 by 2, F value frequency 50 hertz given, and the C value is 10 microfarad. So 10 into 10 power minus 6. The answer will be 318 ohms. The XC value is 318. So next one. So we can substitute XC value in this formula. XC value in this formula. So R value is given 120 squared plus 318 square. Square root of 120 square plus 318 square. The value will be around 340. So next one is phase difference. That is tan inverse XC by R. So XC we calculated 318 and R value given 120. So substituting the two value, we will get a 69.3 degree leading. Phase difference is 69.3. Next one is power we have to calculate, and the formula is VI into cos phi. So phase difference we calculated 69.3. So cos of 69.3 will around 0.353. If you substitute V value given 100, I value we calculated 0.294, and phase this cos phi we calculated here. So substituting all these three value, we will get a 10.38 watt. So this is the easiest method to solve the RC circuit problem. So formula is I given a formula, we can recall. The impedance value is square root of r squared plus xe square. The phase angle is tan inverse xe by r. It's a leading one. Power factor is cos phi, and we can calculate also r by modulus of z. The reactive power is vi cos phi. So this is the formula for calculating the RC series circuits.